Hello everyone, welcome back. So our video today will be on General Chemistry Chapter 9, Solutions. Let's get started. Okay, so there's definitely a lot of important concepts in this chapter. So first, let's talk about, I'm starting this video with the assumption that you understand the basics of what a solute is, what a solvent is, what dissolution is, and things like that. So if you don't, please brush up on those things because those are like the basics of the rest of this chapter. So if you already know what those things generally are, let's get into more detail. So solubility is the maximum amount of a solute that can be dissolved in a given solvent. Pretty self-explanatory. We have complex ions or coordinate compounds, which are composed of metallic ions bonded to a neutral compound or anions. Okay, that's also referred to as ligands. This purple here is just some basic definitions so we can move forward. And the formation of those complex ions increase the solubility of an otherwise insoluble compound. And this is the opposite of the common ion effect, which we'll talk about in a moment. But you can just make note of that for now. So formation of complex ions is the opposite of the common ion effect, because the formation of complex ions increase the solubility of an otherwise insoluble molecule or compound. Okay, so complex ions also involve electron pair donors or electron pair acceptors, as seen in coordinate covalent bonding, which I know we've spoken about in previous chapters in general chemistry. So next we're going to look at these different ways to express concentration. I do go over these a lot in one of the earlier Gen Chem videos, I know that, but just to mention them again since concentration is super important for this chapter. So we have percent composition by mass, which I'd show you how to find in, I believe, General Chemistry Chapter 4 video. There's a mole fraction, which equals the moles of the solute over the total number of moles. There's molarity, which is the moles of solute per liter of solution. There's molality, which we'll see a little bit later, and that's the moles of solute per kilogram of solvent. Then we have normality, which is the number of equivalents per liter of solution. Okay, so, we also have moles, again, mass over molecular weight, never ever ever forget this formula. And then dilution is M1 times V1 equals M2V2. Okay, so now that we've got those basics out of the way and we see all the different ways we can express concentration, we need to take note that concentration is super important when we're talking about solubility. So when I mentioned before here is the common ion effect. So the common ion effect is basically saying that there's a decrease in solubility of a compound that already contains one of the ions that is in the solution. So if you have a solution of, like this one up here, CaPO4, if you have a solution of this and have a compound that has calcium in it, when calcium is the ion that will dissociate in solution, in this solution, that's a little tricky because now you're trying to put calcium ion into a solution that already has calcium in it. So that is saying that the solubility of calcium will decrease when you do that, right? Because the space to dissolve, the calcium space to dissolve has already been taken up by calcium already. So that's the common ion effect. So that's saying that you will decrease the solubility of that compound. Therefore, you will decrease dissociation of your solute. So a way to fix that is to remove the common ion. So that's just an important concept. Then we also have the ion product, which is the same, I don't want to say it's the same, but I'm trying to think of how to say it. It's the same mindset that you use to look at equilibrium, which was chapter 6 video, is the same mindset that you should use to understand this equation here. So the ion product, IP, equals concentration of A to its power of its coefficient times concentration of B to its coefficient. And we're using K here, which is equilibrium constant. So we're going to look at KSP when it comes to solubility. So basically they're saying that the ion product is less than KSP, then that solution is unsaturated. But if the ion product is greater than K, SP, then that solution is supersaturated. And so to understand this part of the video, please look at the Gen Chem Chapter 6 video on equilibrium and come back to this, because this is the same idea but is being applied specifically to solubility. Okay, that's that. Oh, and then there's this one more thing here I wanted to mention, just as a side note that I've seen come up a couple times in my practice, has been just a factor, something to remember, is that a decrease in pH will increase the solubility of a salt that contains a basic anion. But if the basic anion is not basic enough, the pH will have no effect. I know that seems a little out there, and it's like, I've just seen this like twice, and I was like, wow, that's like seems something I should just know. So that's just me trying to help y'all out. So I would just say, make note of that, just read it, try to understand it. Okay, it's definitely not as not a pivotal part of this chapter, but still something important. Okay, next, let's talk about KSP. So like I said, please watch the equilibrium video, because this part is definitely related to that. So if we're looking here, KSP is a solubility product, and it's the equilibrium constant for a dissociation equation. So this is like a regular K, but for SP for solubility product, okay? And S is, not this S, but just S, you'll see it down here, just S, is molar solubility, which is the amount of a substance that can dissolve in a specific solvent. Okay, so let's keep working here. We have an example, because I wanted to show you how to use these things. So if we have this, right, Ca3PO4 subscript 2 solid reacts, right, as a reaction, and it dissociates into 3 Ca2 plus ions and 2 PO4 3 minus ions, okay? These two products are both aqueous. This is a solid, and that's important. So what we do is kind of look at this in terms of S, like we just said, right? The amount of a substance that can dissolve in a specific solvent. So for every negative S, so let's say that this is S, the Ca3PO4 is S. So for if you minus S, right, because you're taking this and turning it into these ions. So for every taking away of S, right, so you're taking this away, for every minus S, you get plus 3S, right, and plus 2S of that. So when we take this one step further and kind of put it in the KSP context, mind you here, I just brought the coefficients, okay? You just bring the coefficients and you replace what this actually is by the S, okay? Just so you can understand it. So for every time you take away this, you get 3 of these and 2 of those in layman's terms, okay? So having said that, KSP, like we said, is the concentration to the coefficient as the power, right? And this again is the same thing as equilibrium. We're taking the products and we're ignoring the solid, right? So this is just the equilibrium K, but SP because it's solubility product, concentration of calcium to the 3, PO4 3 minus to the 2 because 2 is the coefficient here, right? On this one here, 2 and 2. And you take that one step further and replace it with the S's, right, that we were talking about, the molar solubility. So then it's going to be 3S, right, because we said that 3 calcium was, in terms of S was plus 3S. And then the PO4 3 minus 2S here would be represented by that. And then that even further, you can figure this out. So then you have, right, you can do 3 to the power of 3, and then you have the S, so that will give you 27S to the 3, and then 2 to the power of 2 will give you 4, and you're just left with 4S squared because you don't have the actual value for S. And then you have, by multiplying those things, you have 108S to the 5th. So that is just an application of this. I have personally seen some practice questions on this, so I would understand how this works. I know it may sound confusing. I tried to say it in a way that was as clear as possible so you know where these numbers are coming from. But if you need, more examples, look up solubility product practice problems, okay? I definitely have done a couple of these, so it's very useful. And you might be given other information in the question to further solve this, but if you understand this, you should be able to use the information that they do give you to find the answer. Okay, so like we had for our equilibrium, we have Q here as well, but again, we're looking at QSP since it is in terms of solubility product. So if KSP, again, which is showing you at one moment in time how far you are from equilibrium, if KSP is bigger than KSP, did I say that? Sorry. If QSP is bigger than KSP, you will have a precipitate and no more solute can dissolve. If KSP equals, as soon as I say it, I don't know if I've said Q or K, so I'm sorry. If QSP equals KSP, therefore it's in equilibrium and no more solute can dissolve because it's in equilibrium. But if you have QSP is smaller than KSP, there is not yet a precipitate formed and more solute can dissolve, okay? So again, watch the equilibrium video first. This is just applying the solubility aspect to it, which is, very important to know. But if this doesn't make a lot of sense yet, just go back to the previous video. Okay, and then finally, the final part of this chapter is the colligative properties. So we have physical properties of a solution that depend on concentration, not necessarily the identity of that compound, molecule, etc. So first we have Raoult's law, which states that the presence of other solutes decrease the evaporation rate of a solvent. Okay, it says that the solutes basically act as anchors to the solvent particles. So therefore it decreases the vapor pressure. That's just a concept. I feel like it's pretty, easy to understand on that one. Then we have boiling point elevation. This is supposed to say elevation, sorry. It says that the temperature increases, right? When something's boiling, the temperature increases to give the molecules energy to escape the solution. So we have the change in temperature for boiling equals Kb, which will be given in the problem, times the ionization factor, which is Van Holt's factor, which is basically the number of ions that a compound dissociates into. So if we had NaCl, for example, the Van Holt factor for that would be 2, because NaCl, when it dissociates, it forms Na plus and Cl minus, which are each 1 ion. So together, 1 molecule of NaCl will donate 2 ions to the solution. Okay, next, times molality. So like we said over here, we talked about molality. This is the application of that here. Okay, and then for our freezing point depression, it is the same thing, but here you have, it's the temperature that solvents crystallize, right? We know what freezing is. And the change in temperature there is equal to the negative Kf, again, will be given, times ionization factor, which is the number of ions that it gets in the solution, times molality again. And then finally, we have osmotic pressure, which is equal to I times a molarity here, molarity, times the gas constant, times temperature. And this osmotic pressure is just a reminder that if you increase the solute, you will increase the H2O movement, okay? And just give me 1 second. I just want to check one thing that I said to make sure I said it correctly. Yes. Okay, yes. I just wanted to make sure I explained the Van Holt factor correctly, and I did. So yes, one molecule of NaCl will give you 2 ions. So the Van Holt factor for that is 2. Yes, so that is all for this chapter. Hopefully it's making a little bit of sense. Again, always try to do practice problems when it comes to these types of things, because understanding the concepts is one thing, but being able to apply it in the questions is definitely different. So please use these videos, look up more example problems for things that you don't understand, but hopefully it gives you a good basis of like a mental checklist. Okay, I understand how to do that, I understand how to do that. That's more so how I'm using these videos as well. So if you have any questions, please put them below. If not, we'll see you in the next video.